What's up everybody and welcome to another video, and in this video I'll be showing you two ways of creating a quadratic equation solver using Python. The code I'll be writing in this video has been uploaded on a GitHub repository so that you can check it out and try it yourself. And with that, let's get into the video. So I'm here in Visual Studio Code and this is the text editor I'll be using for this video. So the first way of creating this quadratic equation solver is by using the quadratic formula, which looks like this. So the way we are going to use the formula is to break down every step and write it as a line of code within our Python code. So we are going to start by creating a function called calculation. And within this, we are going to start breaking down each of the steps. But before we can start breaking it down, we are going to need to ask the user for the values of a, b, and c so that we can actually get the variables to use to calculate the answer. So for that, we're going to say a is equal to int input, and we would say a is equal to dash. So now I've set the variables to ask the user for the values of a, b, and c. So the next thing we're going to do is to break down the steps of the formula. And the first step is the one under the square root. I'm just going to name this variable first step and perform the expression under the square root sign, and that is b multiplied by b, which is b square minus 4 times a times c. So this is what is under the square root, and that would be our first step. Then the second step would be the square root of the first step, but we can't just find the square root like this. We are going to need a module, and the module we'll be using is called math. So in the second step, which is the square root of the first step, I would just say math dot square roots, then I would say first step. So the third step is to get the value of the numerator, which is minus b plus or minus the square root of b squared minus 4ac. So since we have a plus or minus, we are going to use this second step twice. So the first case is when the second step is positive. So I would just say second step minus b, and the fourth step would be the opposite of that. So the second step would be negative. So to do that, I will just say minus 1 multiplied by the second step minus b. So now that we have gotten all of this up onto this point, we are going to have to divide it by the denominator, which is 2a. So to do that, we are going to divide both the third step and the fourth step by 2a. But since the division by the denominator is actually the answer of that equation, we can just say the first answer is equal to, we'll say third step first divided by 2 times a. So and the second answer would be the fourth step divided by 2 times a. So now these are our answers. So since we have gotten everything up onto this point, we can now return the answers. So I can just say print first answer and second answer. So now when we run this, it asks us for a, so I'll just input the values of a, b, and c, and you can see it returns the answers. But in a situation where this quadratic equation is a perfect square, for example this one, it returns the answer twice. So I'm just going to style the answer a bit. So I'm going to use an if statement to check if the two answers are the same. So I'm going to return it in a certain way, but if they are not, I'll return it in another way. So now when we run this again, it will give us the answers in a different way. So I'm going to use the two cases. I'm going to see when the answers are different. It gives me the roots are -2 and -3, and when I run it again and input a question that is a perfect square like this one, it gives me the answers are -2 twice. But we're not done. Let me show you the problem with this. If I enter a quadratic equation that is unsolvable like this one, it gives me an error because you can't find the square root of a negative number. And if you solve this with the quadratic formula, you would realize that this first step is actually a negative number, but you can't find the square root of negative numbers. So in order not to give us this error, we are going to use a try and except statement so that I can tell the user that this quadratic equation is not solvable. So now that everything is under the try statement, it's going to try everything here. And if it cannot give us an answer, if it is returning this error, then I'm just going to say except value error. Then I will print out that this quadratic equation is not solvable, meaning that it cannot give us any answer. So now we have added our try and except statement. Let's try to run it again and see how it will respond. So I'm going to put in the unsolvable equation like this one, 2, 1, 11, and it tells me that this quadratic equation is unsolvable instead of returning this error. So the final thing we're going to do is to ask the user if he has another question. So I'm just going to place an input to ask the user if he has another question and an if statement to check the response of that question. But this is an error because you can't use continue and break without having a loop. But because I want this to continue asking the user if he has another question until he doesn't have any question, I'm going to use an infinite loop. So everything is now under the while loop. But I also want to ask the user even if the question he puts before was unsolvable. So what I'm just going to do is copy this here and paste it under this except statement. So even if he enters a question that is unsolvable, it will still ask the user if he has another question. So now let's run it one more time. So I'm going to use a normal equation, 4 and 4. It gives me the answer and it asks me if I have another question. I say yes, then I say 1, 5, 6. It gives me the answer again. I say yes, and now let me put an unsolvable equation. I would say 2, 1, 11, and it says this quadratic equation is unsolvable. Do you have another question? But those are all my questions. I'll just say no, and it breaks the loop. The second step is by using the general format of the quadratic equation, which is ax squared plus bx plus c equals to 0. In this method, I'll be using a for loop to loop over the values of c, and this is because the roots of any quadratic equation are between the factors of the c value, both negative and positive. So within the range of the negative of the c value to the positive of the c value is where the roots of the equation are found, and that is why this method is possible. So the first thing we're going to do is to create a function for the first calculation. So now I'm going to create a list to store the roots of the equation. So I'm just going to say answers is equal to an empty list. So as the loop is running, it will append all the answers that it has found inside this list. So now I'm just going to create the loop itself. So this is the general format of the equation. If a times x, which is ax squared, plus b times x, which is bx, plus c is equal to 0. So I want to append that x to the answers list. But up here we haven't asked for the values of a, b, and c. So we're just going to say that right now. Now we have a variable that asks for the inputs of a, b, and c. Let's call the function. It's asking us, so we say let's use one of the examples we used earlier, 1, 5, and 6. Okay, so it's appended all the answers into this, but we didn't actually print the answers. So I'm just going to say at the last stage, print answers. We run this again. So now when we run this, 1, 5, and 6, we use an example from earlier. You can see it's appended the answers to the answers list and it's printed it out for us here. Now there's a problem with this one as well. If the quadratic equation is unsolvable like the ones I explained in the previous method, let me give you an example. If I say 2, 1, 11, it returns an empty list, but that is not what we need. An empty list is not very useful for us. So here we're going to use an if statement to check if the list is empty, and if it is, we'll return that the quadratic equation is unsolvable because the for loop wasn't able to return any x value that was satisfying this condition. So now we would run this again. So now we input the values, the wrong values, 2, 1, 11. It prints out the quadratic equation is unsolvable. Then we would run this again and input a correct equation that can actually be solved. So we'd say 1, 5, and 6. So it returns the answers are -3 and -2. So now we know that our if statement is working and it returns whether it is solvable or not. But now there's another problem with this method. If the value of c is negative, it should return this here even if the quadratic equation is solvable. So now let me show you what I mean. Like this, for example, is a quadratic equation that you can actually solve by factorizing 1, 2, and -24, but it still returns the quadratic equation is unsolvable because this c is negative, and if you look at our range here, it says -c, and we know that negative multiplied by negative is positive, so it is reversing the order of this range, so it is going from positive to negative. But Python doesn't accept range like that, it goes from negative to positive. So to change that, we are going to create another function to run if the value of c is negative. So I'm just going to copy everything here and create another function, and I would call it a different name called calculation2. So this second one would run if the value of c is negative, and I'll call this calculation1, and it will run if the value of c is positive. But if I'm asking for the values inside the function, it won't actually check it, so I'm going to have to remove these inputs here and put it outside the two functions so that it won't ask it inside the function. I want to check for the value of c before it runs either of the two. So what we are going to change here, we are just going to call this regular c because the c is already negative, so we're not going to change anything, and we're going to convert this one to a negative number. So we're going to say -1 multiplied by c, put this in a bracket, plus 1. So everything is going back to the correct order. So since everything here is going to be basically the same, what we have to do now is to create an if statement outside the two functions to check if the value of c is negative or positive. So I'm going to have to put the value of c here to ask the users for input, then use the if statement to check whether the value of c is positive or negative, then decide which function to run. So now, based on what C is, these two calculations would run. So let me run this again and show you how it works. It asks me for A, B, and C. I would say 1, 5, 6. Here the C is positive, so it runs calculation 1. And if I run this again and I make the value of C negative, like 1, 2, and negative 24, it gives me the correct answer. So now the final thing I want to add in this method is a while loop to ask the user if he has any other question. So every time it finishes one of these calculations, every time it is done running one of these functions, it will come down here and ask me if I have another question. And if my response is either of these two yeses, it will continue the loop. And if it is anything other than that, it will break the loop. So now we're going to run it for the last time and check all the test cases we have. We're going to start with an equation whose C value is positive. We're going to say 1, 5, 6. It runs calculation 1 and it asks me, do I have another question? So I say yes. Then it asks me for the inputs again. Then I say 1, 2, 1, 2, and negative 24. Then it says the answers are negative 6 and 4. I say yes, I have another question. So I'm just going to put a non-solvable equation 2, 1, and 11. And it tells me that the quadratic equation is unsolvable. But I don't have any other questions, so I'm just going to say no, or basically any other thing would break the loop. So that is the second way and the end of the video. I hope you learned something from this video. Remember, there will be a GitHub repository containing both codes so that you can try it yourself. Make sure to share this video with others so that they can learn as well. Thank you so much for watching, and I'll see you in the next video.